There is an explosion for enormous amounts of data to be used and stored. In this paper, it will explain the differences and similarities of the four languages as to memory management. This will show that each programming language is structured differently. Each programming language learns from prior ones in their strengths and weaknesses. It will give the difference between the four programming languages as well as their similarities. This paper will show the comparison and contrast of the variants for management memory. What is memory management? According to Wiki, it is the act of managing computer memory at the system level. Memory management essential requirement is to provide ways to dynamically allocate portions of memory to use at the program's request. Memory also needs to be freed when it is no longer needed. When more than a single process is underway, it is critical that an advanced computer system has a way of freeing up memory. There has been several ways devised to increase the effectiveness of memory management. Researching the similarities and differences of each language, it is discovered that each language builds off of each other. For instance, Object-C learned from C, Java learned from Objective-C, C learned from Java, and C++ learned from a combination of languages. As a result, each language is similar. The next few slides will be spent looking at what the languages contain in addition to how each programming language is related. C is a compiled language with a user-based memory management. It uses generic containers such as stack template of int class. The containers can be built for any class which handles memory management. This makes every class, instance, and object will also include memory management. C does not support overloading at all. It has a manual memory management which results in, if there is an error, then the program crashes. The only difference in C++ and C is that C++ allows overloading. C-Pound strengths and weaknesses come from Java. C-Pound allows the creation of generic container like C++. For example, the stack class uses push and pop to search through data, then store. Think of a buffet station. As you're putting the plates in, you're pushing them on the stack. When plates are removed, you're popping them off the stack. It uses garbage collection like Java for its memory management. C-Pound allows overloading only when used carefully so that code tester can be more readable. Java has similarities to C++. It is portable across heterogeneous networks by using client-side JVMs that are either software processors or runtime environments. Java is accepted in global markets. One prominent feature of Java's platform is its automatic memory management. The development of garbage collection, which works behind the scenes, it uses a fixed heap whose maximum size is set when the JVM starts and cannot be resized until the JVM is restarted. In some scenarios where data is read from databases, which may cause the JVM to run out of memory. Object-C is a superset of C. It features efficient and transparent distribution objects. The environment uses manual memory management. Object-C is portable across heterogeneous network by virtue of a near omnipresent compiler. Many programmers assume that their greatest worries are over once they choose such a language, because memory management seems so automatic at first glance. Before developers use a program language, they need to look closely at the similarities and differences. Even though each language is built from a prior language, some differences exist. For example, C# is similar to C++, but gets its strengths and weaknesses from Java. Each language has its set of variables, but no variables have the same exact name. The older languages contain manual memory management, which means the programmer has to call the deleted function in order to free up memory. Dangling references and memory leaks are two types of memory errors. The goal of the memory management system is to reduce the memory footprint of a program in controlling the lifetime of all its objects. Java, along with C#, has developed an automatic reference counting system, which lets the developer forget about the management. This is known as garbage collection. Dangling reference that we've seen in the prior slide is caused when underlying memory is not released, which creates a memory leak. Most of the time, you will find the dangling reference in manually controlled object ownership. The developer has to manually free the memory. Each language is built off the previous language. For example, Java is learned from Objective-C, and C# is similar to C++, but has the same strengths and weaknesses as Java. Thus, the programmer has strategically designed a system that has to work together to function properly. As you see in the slide here, when the counter reaches 0, then the memory is freed back up so it can be reused. In conclusion, all languages have pros and cons to associate with them. A developer has to decide whether he or she wants to manually or automatically free memory. However, if the generic strategy is wrong from your project, then you will have made a memory management error, and you will pay for this error just as surely as if you had coded it yourself.